All righty. So welcome you all to the FE review session for statics and mechanics of materials. So I think we're gonna be waiting for more. We expect more students to join us, but I think we can really start it, and because we are recording the session, so it would be available in overall. Okay. So everyone, welcome here. So it looks that for the people that they are here, I know a couple of you guys. John is here in the house, and Raj is also here. So Jackson and Ahmed, you all welcome. Okay, so to start, we can just start a little bit reviewing of what is a FE, and what is the format, and maybe by then we have more students also joining us. All right. So your FE exam is basically the FE exam has 110 questions. All right, 110 questions. So maybe let me just write a couple of this information as we go. So let's see. All right. So what we are dealing is 110 questions. Okay. So this 110 questions, so for civil engineering part, we have 14 topics, 14 courses in a way we can say. So there are 14 courses that you will be asked questions, all right? So this document that I have downloaded from NCEES, which is really the administration who give this exam and prepare these questions, gives us, right? So we know that what would be the topics that we'll be asking in the exam, all right? So as you can see, maybe let me just scroll down. All right, so we have like a mathematics, a statistics, ethics, engineering, economics, statics, dynamics, mechanics of materials, fluid mechanics, surveying, water resources, structural engineering, geotech engineering, transportation, and construction engineering, all right? So 14 topics, courses will be asked. So this 110 questions will be about that. So this at this session, we are reviewing two of them for you guys. We are reviewing, so let me, all right, we are reviewing the statics and mechanics of materials. All right, so for these two topics, the approximation, the expectation given us, again, based on the NCEES document, 8 to 12 questions from statics, and 7 to 11 questions from mechanics of materials will be given to you. All right. So basically, I just like plug in these numbers and just did like overall calculations. So so sort of the lower possibility for you would be having like a 14% of the questions in your exam from these two topics, and it can go all the way to 21%. All right, out of 110 questions can be asked from this topic. All right, so if you go with like the most number of questions, if you go with that scenario, it means 1 out of 5 questions would be asked about this topic. So it would be quite important for you guys to be able to deal with these problems. All right. So regarding the type of the exam, so I took the exam myself in 2011. All right. So the format, if I'm not wrong, was a little bit different, because now that I look at the format, the information I read from the website recently, from the NCEES website. All right. So I think it is ORG. So let me know if it is otherwise. So in this website, you can get the information about like the detail of the exam. This very document that I have here, actually, it can be found there as well. So the questions, as I said, 110 questions. All right. So they will be asked in 6 hours. All right, they will be asked in 6 hours. And in this 6 hours, that's my understanding from my readings of the exam detail. In this 6 hours, you're gonna have 25 minutes break. All right. So it will leave you almost with 3 minutes per question. All right. So as a rule of thumb, something you keep in your mind and try to adjust the pace of your calculations, you will be dealing with 3 minutes per question in the exam. So it doesn't mean that all the questions are a standard 3 minutes taken for writing them, for getting the solution. It doesn't mean that. One question, even with the high speed, high pace, would be probably like a 6 minutes, 7 minutes to solve, right? But you will have some other questions that they're going to be taking maybe 1 minute, 30 seconds. So average time per question would be 3 minutes. All right. So this is the average time per question. All right. So that is from that. Do we have any questions so far? All right. So you know that you need to use the approved calculators. There is a detail again, and there is a document in the NCES website that you can see what exact calculators can be brought to the class to the exam session. All right. So make sure that that would be something you want to take care of, and you know that this basic calculator, like most of you guys already basically know how to deal with this. It is FX 115 ES. That is very basic, and but it can do a lot of things, and this is one of them that would be acceptable. All right. So make sure that you're gonna be using, you know what calculator to use, and you are using that. You're using that for your practices, because you want to get familiar with the calculator before the exam. You don't want to just like unwrap the calculator and start to use it, because you do not know some of the functions and some buttons and everything. So you need to, in the practices, you have to already use the calculator you're going to use in the exam. All right. Okay. So all right. Let's see what else we have here. All right. So the next thing is, in the exam, you will be given a reference book, a handbook that you can use. And there are like the calculations, the information, the concepts that you can use them during the exam to solve the problems. All right. So this handbook, if I'm not wrong, also, it is available and free in the NCES website. So you can download it and use it for practices. And definitely that's something, again, you want to take a look and be sure that what are there for you, so you can use it later on in the exam, and you almost know the locations for each problem and concept. Because again, there is not long time for you to solve a problem, so you don't want to really just start to look into the document for the first time during the exam. You know, it's just going to be a waste of time. So that document, I have put it here also. That's one of the documents I have sent you. Maybe I can clean this page now. All right, so this is a document. Again, this is one of the ones that I've sent you already through the email. So in this document, for each topic, you're gonna have an information, basically the equations, you know, so you can use, and there is like a index that you can select, and yeah, you can see the contents here, and just look up the concept that you are asked, and just like find the concept. You know, again, you want to be familiar with this handbook. You want to be already familiar, so you can use accordingly for any question asked from you. All right. This is this one. So here we are dealing with the statics, mechanics of material. So these two topics will be covered, and the concepts that actually will be asked to you will be covered during this session. All right. So something you want to do, you want to do some practice tests. So I would say from the NCES website. You can buy practice FE civil document on which, if I'm not wrong, there are like 100 questions for you with the solutions. All right, so you can be using to as a practice. Even I would suggest to use this document. You need to buy, by the way. You cannot download this. If you need to buy this, I think is, if I'm not wrong, it's like $30 or so. So about $30 would be the cost of this. So that is a document that, in my opinion, the best time to do this is just as a last tool for you before taking the exam in like actual exam. You want to take this and basically getting familiar the best with the exam. All right. So in overall, the rule of thumb, the NCS do not tell us what is the rate of acceptance. So what would be the percentage for you to get accepted? But in the rule of thumb, and then like I would say rumors around, it is usually between 60 to 65%. All right. So that is something we want to satisfy. 65% of 110 questions you want to be able to solve correctly. All right, and the last thing is that if you want to take some practices like further than the review sessions provided by our department, if you feel that you need more practices, there are other like resources for you. You can go with. What's going to cost for you to just go there, but they will be applied, and they're around. I don't know, like a school of PE, PPI to practice to pass. PPI to pass would be another source. So these are like a commercialized review sessions that you can go there and just strengthen your knowledge and have a better review. Let's say like a more review for all the courses. One thing I want to tell you is that I didn't go through, when I was passing the exam, I didn't go through any class. So I studied myself. So it is really up to you how you want to deal with that. And by the mean that we have here, the opportunity provided by our department that this review session is going on, I think that would be a great opportunity already here. So if you focus here enough and just like review the sessions, I would say that would be really enough for passing the test. All right. So having this said, let's just start our discussion. So let's see. Okay. So we are starting from the statics. Okay. So on here, let's just start with the topic of resultant of the force system. All right. So as you know, we can always describe a force as a vector. A force vector really is something essential for our calculation, just like a general formation of the force applied. Okay. So we are dealing with the force vector because the force vector can tell us the magnitude and the direction of a force applied to a system. All right. So something to tell you already, this force vector, all right, can be defined in two shapes, right? First, we can say this is the magnitude of the force, right, multiplied by the unit direction of this vector. Remember that? So if I have a unit vector of this direction, u, okay, so the force vector can be defined as follows. Okay. Also, so having this configuration, even before saying something else, the unit vector, as you can see, solving from this formula, it is the force vector over the magnitude. All right, magnitude of the vector. Okay. Something you want to pay attention is that this magnitude is a scalar value. Is it just a number? Okay. The force vector, as the name says, it is a vector in essence. All right. So if we have this configuration, also the force vector can be defined by two components. We can't say, all right, what is a component in x direction? What is a component in y direction? All right. So we can express the force vector with this as well. We can say the force vector in x direction, right? And the force vector in y direction. Two components for the force vector, okay? This x component of the force vector is this, right? It is this vector. What would be this magnitude? This magnitude can be found by saying that f cosine theta, f cosine theta is going to give you this magnitude. All right, so it's going to be your horizontal component. Why I would say cosine theta? Because I create a right triangle, right? I create a right triangle. I can assume that this f guy can be moved here, this fy guy, and written here. All right, because it is the same magnitude, same direction, right? I moved that here just for the sake of showing you what I'm talking about by the sine and cosine. All right, so using the right triangle rule, you know that this cosine theta can be written what? Cosine theta in the right triangle is equal to what? It is the adjacent over hypotenuse. Okay, so from this you can say your fx is equal to f cosine theta. That's what you see here. All right, we can write the same thing for fy. For fy, so fy, if you write the sine of theta, what is the sine of theta? Let's just write it here. Sine of theta. Sine of theta, you know that it would be the opposite, which is fy, over hypotenuse, f. Okay? So from this, your fy would be f sine theta. All right? That's what you see here. This term, fy component, can be said to be f sine theta. Okay? So that's all said. I want you to look at this two guys here, that the x component can be written to be f cosine theta, y component to be f sine theta. That's how also we can define a force vector. So if I want to rewrite it here, so I told you two ways. We can say f is equal to the magnitude multiplied by the unit vector, unit direction of the vector, right? Also, you can say your f, so what was your fx cosine theta, right? F cosine theta. This would be your I plus the y component, f sine theta. This is for the j direction. Also, you can show a force vector or a vector in overall with this configuration. Okay. So if I want to talk literally, I should show you the sign for the magnitude of the vector, right? So that makes sense more for us, right? Because we are dealing with the magnitude of the force vector multiplied by these two guys. It is a complete way of showing a force vector in two ways. All right. Any questions so far? All right. Now, so this was if you are dealing with an angle. If you are dealing with an angle, I told you it depends on if you are looking for the adjacent to the angle that you have or the opposite to the angle you have. You can go with the cosine and sine, and I told you what is the reason for that. Sometimes you are not given the angle. Sometimes you are given this ratio, ABC, right? So from this, you want to find fx and fy, okay? So if that's the case for you, let me continue at the bottom. All right. If this is the case for you, I'm going to give you a shortcut. Really, I'm going to give you the shortcut how to answer this, because I would assume, because again, we want to review this, right? We want to review this session, and also I would say we are trying to find the fastest ways to solve problems, right? Because you know that the time is the essence here. We need to just go with the basically short amount of time and being able to solve the problems, all right? So if you ever deal with this ones, right? If you want to find the fx, this guy, the horizontal component, right? And you are given this triangle, right? It is very easy. So if I'm looking for the horizontal one, I'm gonna select the horizontal side of the triangle, right? Over hypotenuse times f. This would be your fx. Another one. If you want to find the fy, this component, the vertical component, since it is vertical, I would use the vertical side of the triangle. What is the vertical side of the triangle? B, right? B is the vertical side. B, again, over the hypotenuse. Multiplied by the f itself. All right? So if you ever want to deal with this, I would say ratios of the sides, you can just go fast. You would say, all right, I want horizontal projection. I'm going to use the horizontal side of the triangle over hypotenuse. I want vertical projection. I want to use the vertical side over hypotenuse. Okay? So this way you can solve and find the projection of interest for you, what you're looking for really. Questions so far? All right. So let me erase here. Continue. Down here. All right. So on this part, we want to look at, let's see. Okay. So now I want to deal with the system of forces. Now I want to find the resultant of all these forces. Resultant of multiple forces. Okay. So how we can deal with the resultant of multiple forces? So if I have F1, F3, and F2, right? So these are your original vectors, F1, F3, and F2. All right. So what you do, you can find the projection of these guys, right? And then summation of forces in x direction is gonna be your Rx. Or we can show it with Frx, same thing, because it shows with Frx. Then summation of a y direction would be the Ry, which also we can say Fry. Okay? So simply what you're doing here, you project all the vectors to x and y components based on the way I've told you, I had taught you, right? And then you're gonna add all x's together, would be the x component of the resultant vector, and add all the y components, that would be the y component of the resultant vector, as explained here. So think about it here, F1, F1x, F1y, F2, F2x, F2y, F3 vector, F3x, F3y. All right. So if I want to find the summation of for x component of the resultant vector, Frx, x component of resultant vector. All right, would be F1x because it is rightward, minus F2x because it is leftward, plus F3x because it is rightward. So basically, in a way, if you think about it, I assume this side positive, right? Right side positive, rightward force is positive. All right. Let's go for the y direction. This is what? This is the y component of resultant vector. All right. So again, for example, you need to have a basis for the direction. You should say, all right, I don't know, upward positive, downward positive, leftward positive, rightward positive. You need to have a base. For this one, because it was an X, we would say, all right, the rightward positive. We could have also said the leftward positive, but usually we would say rightward positive. For this one, usually we would say upward positive for the Y direction. All right. So if upward positive, you have F1Y positive plus F2Y positive, F3Y is downward, so minus F3Y. Okay, so these would be your resultant vectors. So when you find a resultant vector, it is only one vector as a result of everything. So that FR really can be expressed as FRX and FRY. So you have a new vector. Instead of all the vector in the system, you only have one vector. Okay. So this is what you see here. You have the resultant vector FR. You can derive. It has an X component. It has a Y component, right? As you have found here and here. Okay. So there is an angle in respect to the horizontal direction. That angle can be found with the arctangent of Y component over X component. Right, you know that the angle, the theta, would be opposite over adjacent, right? For the tangent. When we were talking about the tangent of an angle, we would say. So if this is your vector, I do the same thing I did with the projections on top. So I'm going to move this one to this side, right? Look at this. So this is your FRY vertically, okay? So what is a tangent of theta? The tangent of theta would be equal to opposite of the angle, which is FRY, over adjacent of the angle. All right. This is what you see here. So the theta itself would be the arctangent of FRY over FRX. A tip to you, usually the theta, not the usually, but the theta in overall would be calculated from the x-axis and rotating counterclockwise. This would be theta. So the theta is positive when you're rotating counterclockwise from the x-axis. From positive x-axis, positive side of x-axis. All right. Any questions so far? Okay, so let's continue. So if you don't mind, I'm going to erase and continue to the next page. So I hope that you are basically taking in notes, because we need to erase and move on. That's just a way that the Zoom lets us to do. All right, so let's look at this problem. It says 3 concurrent forces acting on the 10th post. All right, there's a 10th post, 3 forces apply. Find the magnitude and angle of the resultant force. All right, first of all, when it says concurrent here, all right, it is talking about the all forces intersect at one point. All right. All right. So if you're dealing with this problem, we want to find the resultant force applied to this post. All right. So what we can do, we need to project these guys, right? So I'm starting with projecting. I don't know, like let's just start with F1. F1 is a vertical force already. So there is no projection. It is vertical. It is exactly the way that you want. You don't have to break it down to X and Y, because you already have only one component for this, no X component. So the F1 is good, no problem. F2 is inclined, all right? So you can project this one. So you have X and Y projection for it, all right? What is a horizontal projection? Would be F2. See, it is adjacent to the angle. Adjacent to the angle, you need to use cosine, cosine 45. This guy on top is, if you think about it, it is opposite to 45. The vertical side is opposite to 45. So you would say F2 sine 45. All right. Now let's go to F3. Let's go to F3. F3 here, it is also inclined. So you need to find the projections on X and Y. You would say this is X, this is Y. All right. What is the X component? It is 600 Newton. All right. So you don't have the angle, you have the ratios. So you need to go with the trick I told you. You want a horizontal side. So you would use horizontal side of the triangle over hypotenuse. 600 3/5. All right. What about this one? The vertical one. The vertical one, you have also 600. All right. Now, again, you want to use the vertical side, because you were looking at the vertical component, vertical project, and you will say 4 as a vertical side over the hypotenuse 5. All right. So now you have all the forces in X and Y, so you can simply add them. Your FRX, this direction positive. Also, you can show this with this direction, with this way of showing. You can see summation of forces in X direction. And I will say right part positive. All right, so what do you have? Starting with this one, as you can see, it is left part, so negative. F2 is 450. Let's just write the way I have written there. F2 cosine 45. All right. You have no other horizontal force except the 600 3/5 plus F3 3/5. All right. So something you don't want to forget is that your F2 is equal to 450 Newton, and F3 is equal to 600 Newton. Okay. This is your X direction. What about the Y direction? Y direction, let's say upward positive. You also can show it this way. Okay. So you can say what? You can say vertically you have, first of all, this red one, excuse me, corresponding to F2, upward positive. All right. Plus F1. F1 is upward. And you have F3, 4/5. Upward positive. All right. So here is F2 for 450. F1, we already know that it is 300. And F3, 600. All right. From this, your FRX would be equal to, let's just punch in the calculator, it would be negative 450 times cosine 45 plus 600 times 3/5. So this one would be negative 318.2 Newton. FRY would be equal to 450 and then we have sine 45 plus 300 plus 600 times 4/5 would be 1098.2 Newton. All right. So your vector is what? Your vector FR is equal to negative 318.2 and 1098.2 Newton. This is your vector. The magnitude of the vector, you know that how to find the magnitude. Remember that we would say frx squared plus fry squared, everything goes to the power of half. All right, so you have negative 318.2 squared plus 1000, just make sure you close the parentheses here, 1098.2 squared, everything goes to the power of half. From this, fr will be equal to you have 1143.4. This is the magnitude. All right. Now the angle. The angle would be, so you can say the theta is arctangent of fry over fix. What is fry? 1098.2. Fr get negative 318.2. All right. So this angle would be, let's see, arctangent. So it would be negative 73.84 degrees. All right. Yeah. So it means the angle you're dealing with would be, so let me just show you somewhere probably. All right. This is your FR. All right. Okay. So the way that I told you the positive is going from counterclockwise from positive x-axis direction, right? So negative means what? Means are you rotating negative 73 degrees. All right. So it means if you think about the line of action of the force, it will create this angle to the x-axis. So this would be your direction of the force. All right. Questions?
Hey, Dr. Soltani.
Yes.
I could be doing something dumb, but how'd you get negative 318?
Because it was negative, the x component was negative. And you make the arctangent of that, it would be negative, right?
I got positive 41.8.
So you are saying arctangent of 1098.2 over negative 318.2.
Or I'm sorry, back for FR.
FRX.
FRX. This one? So you find
Yes, I got
450 times cosine 45 minus 450 times cosine 45 plus 600 times 3 over 5. Oh yeah, thank you. So what we're gonna do, so this value, I'm gonna write it with red, so you can just follow that up and correct it. All right. So let's just correct this one, and this one, and this one, and this one, and also this one. All right, so let's see. So this number is 41.8. All right. So this one will be 41.8. 41.8. All right. So this is squared plus 1098.2 squared to the power of half would be 1098.99. All right. So it would be your magnitude. Then you're going to say FRY over FIX would be over 41.8. So the angle would be arctangent of 1098.2 over 41.8 would be 87.82 degrees. All right. So something like this, meaning that you're dealing with something like this. This is your FR, all right? And this angle is 87.82. All right. Thanks for the tip. Any other questions? All right. All right. So let's continue. Okay, so if we have a system of forces, you can have like all the different forces, you can have moments, all right? So